This lesson is about describing graphs using interval notation. So we'll briefly talk about interval notation. Interval notation represents two numbers which are the endpoints of the interval and whether you include them or not. A parentheses means you don't include them, a bracket means you do. So if we're talking about all the numbers between 2 and 8, not including 2 and 8, we want to not include them, you put the parentheses on it. So this means all x values between 2 and 8. Now this means all x values between -1 and 5, but it includes them like these or equal to inequalities. If you have one that has it and one that doesn't, so 6 and 9, this one has the or equal to on it. This is all the numbers between 6 and 9, including 6, but not including 9. And then this one, if you're talking about going off in one direction or the other, so x is greater than 10, we don't have a number that is at the top end of it, and so we describe that with infinity, but since you can't get to infinity, you need to put an open parentheses on it to describe that end of the interval. So if you're going x is less than or equal to 3, we include the 3, so we have the bracket. But then the negative infinity says we're going in the negative direction with the x values, and we're not including the negative infinity. So that's how we describe things using interval notation. And we want to describe these graphs using that kind of interval notation. So when I look at these two graphs, let's start with this upside down parabola. When I look at this one, I'm thinking about the domain. I'm looking at what's happening with these endpoints. And the arrows imply to me that it's going to keep getting wider and keep going down. So when it talks about the domain, since it keeps getting wider, all x values will be eventually used. Eventually, this arrow will get out to 100, 1,000, 10,000. It will get to any number. So for the domain, how we describe that with interval notation, we say negative infinity on one side because it goes on forever to the left, and then positive infinity to this side because it keeps going on forever to the right. So when we talk about the range though, the range is the y values, the up and downs, domains side to side. We're going to go up and down now. This one has a top point. It doesn't go past this value of 4 on the axis. So since the highest number for the range is 4, I'm going to put a bracket here to say that it actually gets to 4, but then it goes down from there to negative infinity. So I put negative infinity with a parentheses to describe the range. Intercepts are where it actually crosses the axis. It helps us when determining when the graph is positive or negative. If you look at the intercepts here where it crosses the x-axis, this crosses the x-axis at x equals -3, and also at x equals 1. Now those are going to be where the graph changes from positive to negative, so they'll help us with our intervals, because at these points it's neither positive or negative, it's 0, and so we're not going to describe them as either. So positive, this graph is above the axis, above, if you think of this as like water level, this is what's above water, this is what's below water. This is at water level. So the axis, what's above the axis is this part of the parabola. That's from -3 to 1. So I use these two here, and I go from -3, and I'm going to have it be an open parentheses because it's 0 at -3, and then 1 over here because that's when it ends being positive, and at 1 it becomes 0. Now, past that, it goes over this direction. When I'm less than -3, it goes negative. So remember how I would do that to go over this direction to the left past -3. I'd say I'm going off to negative infinity, and I'm going all the way to -3. I don't include the -3 because it's 0 there. Also, it's negative over here past 1. So I'm also going to include another interval where it's going to be at 1 and going off to infinity for those values. Increasing and decreasing have to do with it going up and down. So when I go up, I'm going to go all the way up to this point. So that's going all the way into the maximum point. So down here for the max, I'm going to put that it has a maximum value because it's the highest point, and the maximum value is at y equals 4, which has to do with, notice that has to do with our range, where the highest point of the y value went. Now, for increasing and decreasing, I'm going to increase into it, because for increasing and decreasing, you think left to right. So I go from negative infinity all the way to -1 here, that x value. I don't talk about the y's, it's what x values is it increasing on. So it's increasing from negative infinity all the way to -1. And then it's decreasing out of -1 and all the way to infinity. Last thing I need to mention is that there is a y-intercept. It doesn't impact these intervals at all, but I'm going to put it down anyway. The y-intercept here is at y equals 3. So it doesn't change my intervals at all, though. Now that we've completed the first example, let's go on to the second example. And on this one, we're going to go ahead and describe it also with interval notation. So if I look at the domain, I'm talking about x's side to side, where this graph goes. The furthest over it goes to the left is -1, but it doesn't include the -1, so it's a parentheses, and then it keeps going to the right because this arrow says it's going to keep getting wider. So this goes off to infinity. The range, on the other hand, the lowest point it gets to is this -1 here, but it includes it. It actually gets to the -1, so that would be a bracket for the -1. And then it too goes, it doesn't stop there, it goes past it and goes off to infinity. So this would also go off to infinity. The intercepts for the x, if you notice where this slopes down, where that would intercept the x-axis would be at 0.5, right there. And then right there it intersects the x-axis at 1.5. That's going to help me with my positive and negative. And then the y-intercept is going to be, in this case, it's going to be right there at y equals 1. Now let's talk about where it's positive. It's positive here until we get to 0.5. So that's going to be from, not from negative infinity, because the lowest it goes to is -1. It doesn't actually get there. And so it's positive from -1 to 0.5. And then the next time it goes positive is at 1.5, but then it stays positive all the way off to infinity as it keeps going. Negative here, it's negative between 0.5 and 1.5, because those are zeros, we don't include them, so 0.5 and 1.5. And then it's increasing. So I'm going to talk about this one here, the min or max first. So this is a minimum point because it's the lowest. It's at the range value here where it goes to -1. So I've got a minimum here at y equals -1. All right, so I decrease into it here and I increase out. So it's decreasing here. So let's go down here to decreasing from -1. It's going to decrease all the way to 1, and then it's going to increase out, so it's increasing from 1 off to infinity. So interval notation is a very quick way to describe graphs where x values are between for domain and range and all these other intervals. It helps us understand the graph and describe it very completely and very quickly.